Recording. All right, Jason, this is your turn. Go ahead.
Okay. All right. First of all, thanks everybody for joining me. I'll tell you a little bit about myself. So, as you know, my name's Jason Swett. I am perhaps known to some as the Rails testing guy. I wrote a book called The Complete Guide to Rails Testing. And I also write a lot of blog posts on the topic of Rails testing and other programming topics as well. And then I'm the host of the Code with Jason podcast, also formerly the Rails with Jason podcast. Today, I'm going to give a talk answering a few common Rails testing questions. Over the last few years, I've noticed certain questions that people ask over and over. And so I'm going to address 3 of them today. And if anybody, this is a small group today. If anybody has any questions as I'm going, feel free to just interrupt me and ask, or if you have anything at all to add or whatever as I'm talking, feel free to just interrupt me. That's totally fine with me. The 3 questions I'm going to be addressing are how to make testing a habit, what kinds of tests I write and what kinds I don't write, and then how to decide what level of test coverage to shoot for. All right, so the first item, how I make testing a habit. There's kind of 3 forces, which are laziness, fear, and pride. So this is kind of like if you've ever heard Larry Wall's 3 virtues. I don't remember off the top of my head what they are, but laziness, hubris, and I forget the other one, but this is kind of similar to that: laziness, fear, and pride. So the laziness part is, some people think of testing as like an extra thing that's added on. Maybe you've heard of like a freelancer will quote a project to a prospective client and they'll be like, it's this much. And then the client says, well, how much if we skip tests? As if it's some extra thing. But it's not an extra thing. It's not a time adder. It's a time saver, and it's an effort saver. And so once I made that realization that tests aren't this extra thing, but they're like baked into everything else, they actually make things take less time. They make it easier. That appealed to my laziness because I'm just a lazy person in general. So that's one force that makes me habitually write tests. And then fear. I think we've all probably experienced the feeling of introducing a bug to production. It feels bad, obviously. It's embarrassing when I've introduced bugs, it's been embarrassing to me. It's embarrassing to my boss. It's painful all around. Nobody wants to introduce bugs. And when I discovered automated testing, it made a huge difference in the quality of my work. I'm not a very careful person, and this goes back to the laziness thing. I would write code that's not necessarily super thoroughly tested. Or here's the thing, I would test my work. I would go through and perform manual testing, but there were maybe paths through the code that it wouldn't occur to me to test. And so everything would work according to the manual tests that I performed, but then it would get into production. I would get a bug report and somebody would say, hey, such and such happened, and then it behaved in this unexpected way. I would then go through the reproduction steps and I would think, it didn't even occur to me that somebody might go through this code using this path. And as a side note, one of the benefits of automated testing is that you go into this different mode where as a programmer, you have an incentive to discover that your code works, because if your code works, then your work is done, and you don't need to do anything more. And so you're not incentivized to find bugs. These are kind of opposing incentives. But if you're writing tests, you go into this kind of other mode, or at least I do, where I'm trying to think of okay, what are all the different ways that this could fail? Let me think of all the different use cases I need to test. And when I'm in that mode, I often will think of more use cases than I would if I'm performing manual testing. Anyway, that's the fear thing. The third out of laziness, fear, and pride is pride. I don't want to be seen as the kind of developer who doesn't write tests, because frankly, to me, that's like, at this point, my belief is that if you don't write tests for your code, that's a little bit below like professional grade software development. And I don't mean any offense to anybody who's not writing tests yet, but for me at this point, I put it right up there with like version control and those kinds of tools and those kinds of practices that are kind of table stakes for professional software development now. And so I would be really embarrassed if somebody opened up a code base of mine and saw that I didn't have any tests, or I only had a few tests or something like that. My pride and arrogance leads me to want to make my code as good as it can be. So that's how I make testing a habit. Does anybody have any thoughts or questions or anything before I move on to the next testing question? All right. I see Ender made a comment in the chat in Turkish. I am curious what that says. I'll look that up later on Google Translate. Okay,
No,
my next question. Don't.
I was trying to write the ufuk on DM, but I just write on general. Sorry.
Oh, I see. The next question I want to address is what kind of tests I write. I get some variations on this question. What kind of tests do you write? What do you write tests for? That kind of thing. My answer, which I realize is not a very helpful answer, is pretty much everything. I write tests for just about everything. But I suspect that when people ask that question, they're really asking a different question, which might be like, okay, we have these different kinds of tests we can write, but like, how do you decide which kind of test to write in a certain scenario and stuff like that? And then there's another aspect of that, which is like, I see a lot of people, including, sadly, there's like blog posts recommending writing certain kinds of tests, which are completely pointless tests. So there's a lot of bad education out there of like, here's what's supposedly a good example of how to write a test, but it's actually like the worst possible example of how to write a test. And I'll explain what I mean. I think one of the most helpful lessons with testing is the lesson of testing behavior, not implementation. Now, I'll give an example of that as it pertains to Rails tests. So here's a bad example that I see a lot regarding Rails. I'll see tests that check for something like the presence of an association, or the presence of a certain method, or the presence of a validation. And these tests don't really test anything. Again, these tests are testing the implementation, not the behavior. Let's say, for example, I have a customer table and it has an association with another table called orders. Even though I have that line in my customer model that says has many orders or whatever, it doesn't really do me any good to write a test that checks for that line that makes that association, because what I'm really interested in is the behaviors that that association enables. Because think about it this way. If I deleted that line, has many orders, then all the behavior that uses that association would break. So if I have tests for that behavior, then those tests would break also, meaning that my test that I have that just checks for the presence of that association is redundant to those other tests that actually test the behavior. So in that scenario, that test is useless. And then let's say that that association doesn't enable any behavior. Well, then that test is pointless again, because why is that association even there? What value does it have if it doesn't enable anything? So in both those scenarios, my test that checks for the presence of that association is useless. So those kinds of tests are a waste of time. And libraries like shoulda, if you're familiar with that library, all that does is make these pointless tests easier. And so I don't use the shoulda library because it helps me do something that I don't think you should even do. And so that's testing behavior versus implementation. Another comment I want to make regarding what kinds of tests that I write. Ender asked me this question when I was on his podcast. I don't think I gave a great answer, and I've thought about it more since then, and I've read some things that I've wrote in the past but forgot that I wrote. This is the kind of thing where I forgot what I think about this issue because I don't think about it all that much. But sometimes I skip tests. I admit that sometimes I skip tests just out of laziness, and that's bad. I shouldn't do that. But sometimes I skip tests and I think it's justified and appropriate. And here's when I skip tests. When there's a scenario where the cost of the feature breaking would be really low and the nature of the failure would not be a silent failure, but it'd be something that would be guaranteed to be noticed if it went wrong. If those things are true, and if the test would be very costly to write, then I usually skip the test. And I'll repeat that. If the test is really costly to write and the cost of failure is really low, and the failure will be such that it's not a silent failure, then I think the cost of writing a test is actually greater than the cost of not writing a test. And that's even more true if it's the kind of thing that only gets used like once every couple months. So those scenarios, I usually skip tests, but that's like the vast minority of cases. Okay, so that's what kind of tests I write. Let me make one more comment. This isn't in my notes that I keep glancing at here, but I'm thinking of it now. In Rails, there's various kinds of tests you can write. I use RSpec, so I'll use RSpec terminology. You can write system specs, model specs, request specs, a number of other kinds of specs. I mainly write model specs and system specs because for me, the meat of my application is in the models. And so I think it makes sense for the majority of my tests to be where the majority of my code lives, which is the models. But your model tests, they only test from a certain layer downward. They don't test anything to do with the UI, of course. So your models could be completely working, all those tests are passing, but you could even disconnect the entire UI. You could delete all your JavaScript and HTML and those tests would still pass. So obviously that's not sufficient by itself. So I like to have system specs for the happy path for most of my stuff. I'll have a relatively small number of coarse-grained system specs and then a relatively large number of fine-grained model specs. And then lately I've been writing more and more request specs because those are a little lighter weight than system specs, but they largely accomplish the same thing. But that's kind of the mix of spec types that I write. All right, third and last question that I want to address is what level of test coverage to shoot for. This is a question that comes up a lot. And I have a stance on this that I haven't heard a lot of other people express. And I don't know if that's because my stance is controversial or for some other reason. But my opinion on that is that you shouldn't shoot for a test coverage number, shouldn't shoot for a percentage. That's kind of thinking about it totally wrong, I think. Here's how I think about it. Why do we want to have tests at all? We want to have tests so we can enjoy the benefits that tests bring. And what benefits are those? Well, we can code faster with fewer defects. Having good test coverage enables things like continuous delivery and continuous deployment, which are pretty hard if you don't have good test coverage. And so here's how I think about it. This is a case where like people are desirous of putting numbers on these things, but I think this is more of like an emotional thing. Like, is my development practice a painful process or is it not? Does anything hurt? If not, then maybe I'm fine. Maybe I don't need any more tests. But I've never really encountered a coding team that doesn't have some of these pains. And I'll say the inverse of these benefits. If you don't have any tests or you don't have many tests, you might not be too comfortable with the deployment process. Deployments might be this big shuttle launch event where they only happen very infrequently, maybe once a month or once every couple months. There's a huge amount of manual testing that needs to be done before each deployment. Stakeholders are nervous about deployments. Developers are nervous about deployments. Deployments are often accompanied by these big firefighting events where you deploy, inevitably something goes wrong. Maybe you even deploy and you need to roll back, and then it's this embarrassing thing because you tried it, now it didn't work, and you need to try again. And then it's even more nerve-wracking because something just went wrong. You could have those pains around deployment. And then, of course, it's very common for a code base to be more full of bugs than the development team and the stakeholders find to be acceptable. That can obviously be a symptom of having too few tests. And then the development process. If it's a long, tedious development process that involves a lot of manual testing, I don't know about you guys, but I really don't enjoy manual testing. I like to design the machine. I don't like to run the machine. And so for me to like have a list of steps to carry out and have to manually carry out those steps, and then each time I make a small change, I have to go and run through all those steps again, that's very painful for me. So if a team has those kinds of pains, and a lot of teams do, then that's a sign you could probably benefit from more automated tests. If you don't have too many of those pains, well then great, you're probably good. But again, the typical case is that you do have those pains and you could benefit from more tests. I think that way of thinking about it is much better than setting some arbitrary number like we need to have 60% test coverage, we need to have 80% test coverage, or whatever. That might leave the question of, well, if you don't have like a test coverage number to shoot for, how do you like enforce it, or how do you have enough? How do you do that? And I would take that back to the testing habits question. For me, once I understood that tests were a time saver, not a time adder, and once I understood that coding could be not just faster, but more enjoyable, and my work output would be better with tests. Plus, crucially, once I developed the actual skills of testing, then it became unimaginable for me to code without testing. And for me, saying it's unimaginable for me to write code without tests is a much better incentive than saying I have to write tests because otherwise I'm breaking this rule that says we have to have tests for all our code. That's much better to me. In case anybody's curious, the last time I checked my test coverage, it was at like 96 point something %. So these habits, and that was without like keeping an eye on it over time. This is just what naturally arose as a result of my testing habits, and then I just checked out of curiosity. So these habits do lead to what I think is a pretty high level of test coverage, even though it's obviously not 100%. So to summarize that one, the point of testing is to enjoy the benefits of testing, not to hit an arbitrary number. All right, so let's summarize those three things. How do you make testing a habit? I make testing a habit through laziness, fear, and pride. And I think if you have a healthy level of laziness, fear, and pride, then those things can drive you to write tests. When you're thinking of what to test behavior and not implementation. And then for test coverage, don't shoot for a number, but rather listen to the pains that you have, and in the areas you have pains, maybe those pains are telling you that you need more test coverage. And in order to have a good level of test coverage, again, don't use that number as what you're shooting for, but rather try to develop good testing habits. And your good testing habits are likely to ensure that you're going to have good test coverage. And those are my answers to those 3 testing questions.
Yeah, great. Thank you. I have a question about testing to tests. Sometimes you write test and okay, everything is okay. Our test is green. So, but at some point we change the code and still our tests are green.
Mm-hmm.
So how can we test our test scenarios actually?
Yeah, that's a really good question. So what you're talking about, of course, is a false positive. It's a test that doesn't actually test the thing you think it's testing. And the way to avoid having those false positives is to make sure that you run your test under a condition where the thing your test is testing doesn't work. And when the thing your test is testing doesn't work, your test should obviously fail. And significantly, your test not only should fail, but it should fail in the way that you expect. And I want to talk about a couple mistakes around that. So sometimes I see people, they hear that idea that you should always see your test fail before you see it pass to protect against the false positive. People understand that, but then they perform their test in a way that doesn't give them the knowledge that they actually need. So like they'll write the test and they'll write the code and then they'll see their test pass, and then they change the test so the test checks for something different, which makes the test fail. And that's wrong, because that's not testing against the that's not ensuring the validity of your test. That's just changing your test to a different test. So you want the thing you want to check is your actual test that you're going to keep. Because if you take your test and then you change it to something else and you change it back, what you tested was this other thing that you're not keeping, but you want to test the thing that you're actually going to keep. So keep your test, then go change your application code so your application code misbehaves. Then run your test, and if your test fails, then you'll know that under the scenario where your application code misbehaves, your test fails. And then under the scenario where your application code behaves properly, then your test passes. So to underscore that, when you're performing that test, that check against false positive, change the application code, not the test. I said I wanted to address 2 things. I forget one of the 2, but that was one of them, but I think that was the more important of the 2. So that's how I do that.
Maybe we can add, so for tests that you add to the system that are addressing a certain failure mode that you've found in production, let's say, right? Like you've observed the failure mode of your application in production. I think like what the best practice is to write the test to replicate the behavior first, see it fail, and then fix it in code, and then see the test pass, so that you're confident that you've actually solved the problem that you are observing. And you're also confident going forward that it won't regress in the future either.
Yeah, I think that's a great point. And you actually reminded me of the other one of those 2 things that I was going to say, which is when you write your test and you see it fail, it's important not just for it to fail, but for it to fail in the way that you expect. Because it could fail because of some, I don't know, as an obvious example, you could just have a syntax error in your test, and then your test could fail because of that. And that's not a valid failure because it's not failing in the way you expect. Your test could still give a false positive if you fix that syntax error and run it again. So again, make sure the failure you see is what you expect. But yeah, I agree with you. I said it the first time and now I can't say it again. UFOOC
Ufuk. Yeah.
Ufuk.
Yeah. Fine. Yeah.
Yeah, when you encounter a bug in production, I like to do the same thing that you said, which is write a test that replicates those conditions so that that same thing won't regress in the future. Anybody else have any comments or questions?
Yeah, I actually have a question related to the active model callbacks. I have a question about like, what is the best way of avoiding to use set and skip callbacks methods in the testing environment? Because like I'm seeing a lot of test cases where we have to in the past projects as well. I saw this one where we have to just call like skip callback first and set callback. So like because when we create an active record instance, it basically fires those callbacks, which has some side effects like calling some workers or calling some other service objects, whatever. So it's also related to the question of like, what is the testable code, like how you can write testable code so that it doesn't have these kinds of side effects. So do you have any suggestions related to that?
Yeah, that's a really good question. So whenever I see test code that makes the application code behave in a way that's different from how the application code would actually behave in production, to me, that's a little bit of a code smell. And a code smell, of course, isn't like something that's always bad. A code smell is like, this is maybe something we should take a closer look at. And so that scenario where you're testing something that has an active record callback and the callbacks get disabled, that's something that I would want to take a closer look at that where I encountered it. Because obviously any time that you're making the code behave differently in order to test it, you're reducing the parity between how it behaves in production and how it behaves under test. And that gap between how it behaves in production and how it behaves under test is an opportunity for bugs to be in that gap. Having said that, it's also a good idea sometimes to test the thing you want to test in isolation, because if in order to test anything, you had to test that thing plus all of its dependencies, then a lot of your tests might involve a huge amount of like irrelevant setup work, and it would distract from the central meaning of that test. And that's bad too. So there's like two bad scenarios that I want to try to avoid. The one bad scenario is making the code under test behave differently than it would in production. And the other bad scenario is pulling too many dependencies into the picture when I'm testing something. And so I wouldn't say that scenario of disabling the active record callbacks is like always good or always bad. That's something that I would take on a case-by-case basis. I would say that I don't have that scenario in my application at all. And I'm thinking about like, why don't I have that? One reason is because I just don't have a lot of callbacks, period. I do use callbacks just pretty sparingly. And so I guess it depends on what's in the callback and how relevant it is to the thing that's being tested. I don't know if that addresses exactly what you're asking, but those are kind of some of my thoughts.
Yeah, I can give an example to this one. So like, let's assume we have a model which has an after commit create callback, something like that. And it basically makes sure that like, I don't know, warming up a cache in Redis or memcached, something like that, let's say. And when we create an instance of that model, when we test, like, let's say, basically, when we create a factory girl, factory bot, whatever instance, And when we want to test actually another behavior, let's say it has a method on the model and we are just trying to test it. Because of the after callback, we have to like, I know that like this is a code smell problem, which is bad, but at the same time, I'm seeing this happens a lot in the Rails projects. So in order to achieve that, maybe like we can use build, but sometimes you need to have the record actually in the database so that you can also have the relations, etc. So a realistic scenario I can describe it as like that.
Yeah. Okay. So here's what I would think of that. And this goes back to what I said about like how I'd take it on a case-by-case basis. So if you need to create a record and there's an after create callback that says like, after we create this record, prime in a certain cache or something like that, and you want to test this method on that object that has nothing to do with the caching, then I would absolutely disable that after create callback if it was expensive or something. I would have no hesitation to disable that after create callback because it's irrelevant to the thing I want to test. And that's the same concept as like mocking and stubbing irrelevant dependencies, because we want to test the thing we're testing and not the thing's dependencies. So in that particular case, I think it would be not only fine, but I think it would be the best thing to do to disable that callback.
I see. So like if it is inevitable, we should do that, right?
Yeah, the way I would put it is if the behavior in the callback is irrelevant to the thing being tested, then I would disable the callback.
I see. Yeah. Okay. Thank you for the response there.
Yeah.
Okay, I have a question. First, thanks so much for joining us today in our community.
Yeah.
You mentioned you don't like using the shoulda again or validating, testing the validations, etc. And you said those are implementation and testing the implementation is bad. But I would think those are not like implementation, but the behavior of the database or behavior of the data, and the behavior could change from client to client. And when I think from the test-driven development point, I can see the point of shoulda library. What do you think about that?
For validation specifically, I've changed my mind over time. I used to have the exact same opinion as you. My opinion was that validations were an exception because validations are behavior, which is true. But I've changed my opinion since then because and let's talk about just one-liner validations for a second, not like custom validations. Validations that are one-liners, think about like what it would take to cause a regression. You'd have to delete that one-line validation. And then your test would catch that. And that's like a good thing to protect against in theory, but I've like never ever had that happen in practice where I like accidentally delete a validation. And to me, that's why that's pointless, is because it protects against something that I've never seen happen. So that's why I think about that way. But if there's something that's like a more complex validation where I'm actually defining my own custom validation, then I would certainly write a test for that because it's not just a one-liner. But that's an area where like the strength of my opinion is fairly low because, like I said, I used to have the same opinion as you and I've changed my mind. I could see myself maybe changing my mind back again to your opinion. So I don't have a super strong opinion about that.
All right, thanks.
Mm-hmm.
I guess if the validation had like complex if logic or something, then if it was dependent on the state of the model or on like who was accessing the model or something, then I guess you would want to test that.
Yeah, let me put it this way. So yeah, I totally agree with that. I'll put it this way. So there's like mistakes and there's accidents. So like you can do something by, okay, so like if I like am walking and I like kick over a can of paint, that's an accident. Or if I like make an investment in like a stock that I shouldn't have made an investment in or something like that, that's not an accident, that's a mistake because I did it on purpose, but it was the wrong thing to do, so it was a mistake. And so when we write tests to protect against regressions, we're trying to protect against mistakes and accidents. And with a validation, you could remove a validation by mistake. And since, we're not dumb people, we're going to go in, we're going to remove that validation, and then we're going to remove the test for that validation because we want to remove the validation, so we want it totally gone. So that kind of test doesn't protect against a mistake. The only thing it protects against is an accident. It only protects against me like trying to delete lines 4 through 10, but instead I delete lines 4 through 11 somehow. And like, that's just a mistake that people don't really make, I don't think. So that's my second attempt at explaining like why I don't find those tests valuable, because they protect against something that doesn't really ever happen. All right, any other thoughts or questions or anything?
So I have a question, but the question is going to take us away from Rails land.
Okay.
So I've been doing a lot of infrastructure work the last few years, and I keep running into situations where I'm working on building a new gem or something, and it needs a lot of like activation energy to even start to write like a test framework for it.
Okay.
Because like the thing is so low level, sometimes like every test needs to run in isolation, because like if tests run not in isolation, then they like change the state of each other, just because like one of the tools that I'm working on is a Ruby interface file generator called Tapioca that we've been developing to help our gradual typing process. What it does is it uses runtime reflection to actually discover the constants in memory and their methods and their subconstants, et cetera. And in order to write a isolated test case for it, we need to create like setups with like random constants in memory, but then they need to be gone afterwards because otherwise they infect the other test. So like that needs to be run in isolation, and you need to create like this whole infrastructure to be able to even write the first test that we already have inside of Rails for free. So for Rails, that's kind of easy, right? Like imagine if you didn't have any of the layers of supports that you have for writing a spec, like a scenario spec or a controller or a model test inside of Rails. So for projects like that, I find it sometimes really hard to get over that activation energy to start writing the first tests, and then afterwards it's easy. But do you have like any recommendations for people who are faced with that?
I don't think so. I've never done that kind of work myself. So you're talking about like building libraries in the form of gems, that kind of thing?
Yeah, so I can give you another example. Over the last hack days at the company, I actually built an in-memory language server provider for Rubocop. It integrates to Visual Studio Code or other editors through the language server provider protocol. It like talks over standard in, standard out. It's like a JSON RPC protocol, and then it like hands the whole thing to Rubocop in a Ruby process, and then uses the the Rubocop output to send diagnostics back to the editor. And like, I still haven't been able to write even the first test for it. It was like a hack days project, but then I was like, how am I going to even like set up a standard in, standard out JSON protocol mocking thing to even feed the scenario to this thing in the first place, kind of thing?
Yeah. Yeah, you know, now that I think about it more, I have encountered challenges like this. Like one time I taught this class and I had the students, it was actually, now that I look back, I realized later that it was not a great pedagogical exercise, but in order to get the students familiar with testing, I had them write this like command line program, because I figure, well, we won't have the baggage that's involved with Rails.
Yeah.
And so it was this program you could manipulate by, you were presented with like multiple choice options, then you would select one and you could type in free text to the command line and stuff like that. But then I realized that you somehow had to write the test infrastructure to test all that. And so it ended up that in order to test it, you had to give your test like a script. So I would give it like an array saying, when you're presented with this question, give this answer. And then if it gives you this question next, that's the wrong question. That's bad. Okay. And then this other scenario, give the question this answer. And then if it gives you this other question next, give it this answer, and so on. And there's this huge like amount of plumbing work that was necessary just to even be able to write tests for this kind of program. So I think the answer to that is probably just that that's work that we have to live with and there's no way around it. I don't like that answer, but I think that's probably it.
Thank you. And I think there's Aruba for that, like testing CLI clients. I think it's
Oh, really?
from the same people who built RSpec, or no, Cucumber. Yeah, Aruba is like a way of doing CLI testing.
Oh, interesting. I'll have to look at that. Yeah,
Sure.
I didn't know about that. Okay, what else?
I can make a comment about your presentation. It's not a question, but while you were presenting that, you said you would prefer to write model tests and system tests. So I said, like, what was system test? Is it feature test? And I Googled it while you were talking, and I clicked on the first thing, and it was your site. Yeah.
Yeah, that's funny. Yeah, I've put in a lot of time over the last few years writing like every testing related blog post I can think of. But that's nice to know that you came across mine.
Yeah.
Okay. Well, any other questions or comments or anything, or is that it?
About that, actually, for example, Char didn't know what was system testing. Do you think the terminology is complicated right now? A lot of things are named differently from different groups of people. What do you think about that?
Yeah, it's pretty bad. So just within the Rails world, there's terminology problems. Like, good luck to a beginner trying to figure out like what's a feature spec versus a system spec. And what's a request spec versus a controller spec, all that stuff. So there's all sorts of terminology problems just in Rails. And then in the broader world, there's no like consensus on testing terminology. So for example, here's a good example. What's an integration test? Like if you ask 10 people what an integration test is, you're not going to get just one answer. I don't know if you'll get 10 different answers, but you'll at least get more than one different answer, because an integration test means different things to different people. Same thing with like end-to-end test, all that kind of stuff. And so I think one of the most useful things to learn to somebody who's just getting started with testing is that when you encounter a term, you shouldn't give like any weight to that term, because the terms are very ill-defined and fuzzy. I don't know when we're going to get that all sorted out, but probably not anytime soon. It's just one of the challenges of the immaturity of that area of software development. All right, sounds like maybe that was the last question. Maybe we turn it over to Ender now. You're kind of the MC of the event.
Yeah, thank you for everything, Jason. That
Yeah,
was
thanks for
a
having me.
great talk. Yeah, that was a great talk, and the questions were great. So, and the last word, what should you say?
Oh, what's my last word? I don't know. Maybe I'll just summarize what I said earlier. I picked these 3 questions because I think they're kind of important ones. Like, I think making testing a habit is one of the most valuable things you can do. And then focusing on writing tests that actually have value. Obviously, it's better to write valuable tests than pointless tests. So just remember that test behavior, not implementation. And then regarding test coverage, that one, I included that just because it's such a common question. But again, I think you shouldn't shoot for a number, but rather rely on your testing habits. And if you're feeling pain in your development team, then that's a sign you could benefit from more tests. So those are kind of my closing thoughts.
Great, thank you again. Okay, I'm closing the record. So, okay. Oh,